see a picture of a couple of diamonds. And so typically we know that the bigger the diamond is, the more that it costs. And that's actually related to something called carats, and that determines the weight of the diamond. There's also something else that determines diamond cost or price, and that's the clarity. So you see this one's a little dingy and this one's a little clearer. So this one would actually be worth a little bit more. So not only does the weight of a diamond affect it, but also the clarity of the diamond. So the reason I'm telling you this is because we've got some data here that actually shows 20 different diamond prices and their weight. So here's the weight in carats. Here's the actual price that those diamonds sold for. And then here is actually a predicted price that, based on a trend of data, it should have sold for, but you can tell that it doesn't necessarily sell for that. What we've done is we've taken the data here and we've displayed it in a scatter plot. And in the scatter plot, it shows the weight here, so all those values, and the price here, and you've got all your scatter plot values. But it also gives us this line that you see in the middle here. And the line that's drawn in the middle, this is the equation of that line. And it says the function described by this equation is a model of the relationship between the diamond's weight and its price. What the model does is it helps us predict what the price is going to be based on the weight. And these predicted prices are shown in that third column. So if, for example, we knew that something weighed 1.62 carats, then we'd go up to where that is on this line and we would say, okay, this is now our predicted price. It might not be the actual price, but it's our prediction, and that's what's in this column over here. So based on all that information, we're going to answer a couple questions. It says two diamonds that both weigh 1.5 carats have different prices. What are their prices? How can you see this in the table and in the graph? So if we look at the table, we want to find 1.5 carats. So if we look down, I see 1.5 carats right here. And we want to know what their prices are. So here's the two prices of those. And notice that the predicted price is the same because the predicted price is based on the weight, but here's what they actually sold for. So let's see if we can find those on our scatter plot as well. So we would go over to 1.5 and we would go up and we'd see these 2 points. So this represents the 2 points. So the two prices were 7,474 and 5,904. So in the table, we can see just by going to that value. And then in the graph, we can see by finding those 2 points in the scatter plot. The model predicts that the weight of a 1.5 carat diamond is actually going to be the price of 7,189. So how do you see that in the graph? And then how can you actually use the equation for that? So in the graph, we could see that by going to 1.5 and going up to where it is on the line. And if you look over here, this is approximately 7,189. So we can't tell that exactly from the graph, but we could get the exact value from this equation because this equation represents the graphed line. So I know in this coordinate plane that my x values are the weight and my y values are the price. So if I know that the weight is 1.5, I could actually substitute that in for x and figure out what my price should be or my expected predicted price is. So what I would do is I would take that equation, I would substitute 1.5 for x. Here is when I substitute in 1.5, I multiply those two numbers here, and then I subtract this last number, and I do get what they predicted the price would be, because what I've done is I've used that model to help me predict what would happen if I had a diamond of 1.5 carats. A diamond for which the model makes a very good prediction of the actual price, and how could you find this in the table and in the graph? So in our table, we could look through, and if it makes a good prediction, these numbers would be really, really close together. So if you look through all these numbers and figure out which ones are the closest together, you'll actually find that these two are the closest together. So for the weight of 1.2 carats, this was the best prediction, but it's easier to actually see in the graph. So if you go to the graph, Your best prediction is going to be any of your points that falls on the line or really, really close to the line. And you can see this point here, which is the same point I just showed you in the table. See how it looks like it's almost exactly on that line? It means the model made a really good prediction for what that diamond would sell for. Find a diamond for which the model's prediction is not very close to the actual price. How do we see it in the table and in the graph? So in the table, we could go and we could find where the actual price and the predicted price are very, very different. So they're the furthest apart from each other. If we look here, these values are almost $1,000 off. So it was a really bad prediction for that diamond. And you can see that a little easier in the graph, because if you look at the graph, it's going to be the value that is furthest away from your line. So this is actually this point right here. See how far away that is from the line where it should have been up there, but now it's actually down here.